Right, so I wanted to show you these. These are the clips off a bike pannier bag. They've snapped off when we're cycling along. I was looking at them in more detail because I'm 3D printing some more to stick on the bag so we don't have to get a whole new bag. When I was taking the measurements, I saw like something quite interesting. Can't really see it on these because they're broken, but we've got a second bag because they come in pairs here. So the thing that I found quite interesting when I was looking at it is that we've got a weakest area just here. The reason why it's the weakest area is because it's one of the thinner areas, and it's the thinnest area furthest away from the load point. So if you've got your load coming here and say it twists a little bit, the load's coming out here, that's the thinnest piece, and it's the thinnest piece furthest away from the further away something is from the load, the more torque's generated, so the more it's stressed by bending. So that's the naturally weakest part just here, there. But also on the naturally weakest part is a mould line. I hope you can see it. You can see that there's a mould line. It's not particularly well lined up. There's quite a sharp edge all the way around. You can like dig your fingers on it and it's quite a sharp edge. The reason why this is, I would regard, such an issue is because, one, the misalignment maybe reduces some effective area, how much material there is, like cross-section connected. But the main issue is that sharp edges affect like stress concentration, so you get really high stresses along this line with an already highly stressed area of the part. And these sharp edges also assist crack propagation. So it's like when you scour glass or nick a packet of crisps with your teeth, it like either the glass snaps easily or the crisp packet tears easily. It's a similar sort of effect. It's like the parts come pre-scoured for snapping. And I found it interesting because if we just moved this mould line to somewhere else, it would have made the part a lot stronger and a lot more resistant to fatigue, which is quite vital for a part that's holding like the weight of a bag on bumpy roads. It gets a lot of flexing, so it needs to be quite resistant to fatigue. This I thought was quite fascinating because the part would have been significantly stronger, a lot more resistant to fatigue if this was all smooth and the mould line was moved to somewhere else that wasn't at this weakest point in the structure. And also it wouldn't have required any more material per part, like the per part like grammage of plastic used would stay the same and the part would be stronger just with a injection mould design change. I thought that was interesting and worth sharing because it's something you don't necessarily think about. I think people think of injection moulding as plug and play. You just make your part and it's perfect. But in this case, the mould line has had a significant effect on the strength of the part. So it's almost like the manufacturing process is as much of the design process as the design process itself. Right, anyway, thanks for listening. Hope you found that interesting. See ya!